Hi, in this video I'm going to show you guys 3 examples of finding derivatives of trig functions. For exercise 14a and 14b, for the homework that you guys did, they were sort of the basic intro type, right? These 3 examples will be a bit harder, and we will come across all the knowledge that we know of finding derivatives. Okay, so let's get started. So here, the first example, they want us to find the derivative of y is equal to e to the power of x sine x. So the derivative of that, it will be dy dx. So I hope you guys see that we are going to apply power rule, right? So we have e of x. This is my exponential function. And my sine x, that is my trig function. So I have an exponential function multiplying a trig function. I need to use power rule. Okay, so for power rule, when we are finding derivatives using power rule, pretty straightforward. So I'm just going to keep my e of x first. I'm keeping that, and I'm going to differentiate my sine x. When I differentiate sine x, I get cos x. And then plus, right, plus. Now I'm going to keep my sine x. I'll put that in the front. Whatever I keep, I put that in the front. Right, this is my sine x. So this is my sine x, and then I'm going to differentiate my e of x. So differentiate e of x, I get e of x. Now if I simplify this, it will become e of x cos x plus e of x sine x. And you can leave it like that. Okay? That's the first example, simple product rule. Okay, now let's look at the second one. Okay, second example, they want us to find the derivative of s of t. So normally when we use s of t, that could be displacement. Remember displacement? In chapter 7, when we first learned about derivatives, the word problems is always about displacement, velocity, acceleration, right? So assuming maybe like a bee goes around a circle the whole time, or maybe you could have maybe the Ferris wheel, one of the cars goes up and down the whole time. And if I want to find out how fast it is going, this would be a possible scenario, okay? But anyways, so in this example, they want us to find the derivative of s of t. So s of t is equal to ln of sine t. So s prime would be, so in this case, which rule do you think we're going to use? So on the outside, I have an ln, right? On the outside, I have an ln function, natural log. And the inside, I have a trig. I have a trig inside a natural log function, an ln function, right? So here we're going to use chain rule. Okay, because my trig is inside my ln. So when I apply chain rule, we are always starting from the outside. So I'll put that. That's my first step. I'm going to find. So differentiate ln function, it is simply 1 over whatever you are taking the ln of, right? 1 over that. Okay? That's the first part. Not done yet. Multiply it by. Now I'm gonna my second derivative will be this. The second derivative I'm gonna find is the trig function, the inside function. So if I differentiate sine t, I get cos t. So this becomes cosine t over sine t. And that's it. Okay? So here we're applying chain rule. When we do chain rule, we're always doing the function outside, and then we do the function inside. So derivative of the outside, which is ln, that gives 1 over whatever, right? Whatever we're taking the ln off. And then that's my first one. And then if I do the inside, then that's my sine t, derivative of sine becomes cosine. So there you go. Okay, last one. Okay, this looks a bit more complicated. So here we have my y is equal to cosine x cubed multiply sine x. So this is multiplying. So technically we should have product rule, right? Product rule. So we should apply product rule. Now, if you look more carefully, cosine x cubed, let me rewrite that. So my y is equal to cosine x, the whole thing to the power of 3, multiplied by sine x. Now, if you look at this part, isn't that a trig function inside a cubic function? So in that case, we have to apply chain rule, product rule, and we also have to apply chain rule, right? Because we have a trig inside the cube function, right? So we have to apply chain rule. So let's do this. So my dy dx, my derivative is gonna be, so let's say I'm going to keep, so I'm gonna do my product rule first. My product rule is this, right? So I'm keeping that. I'm going to differentiate my sine x, so that gives me cosine x. Plus, now I'm gonna keep my sine x, and I'm going to differentiate this, which I will need to use my chain rule. So what you can do is, I recommend you to do this on the side. So I'm going to do this over here. So let's say, so in this case, I need to find if my y is equal to cosine x to the power of 3. So what's my dy dx? Right. So again, this is a trig in a power function, a cubic function. So I'm going to start from the outside. The outside is the power function, so the inside doesn't change. So I'm just going to simply bring the 3 down, that 3 in the front, and then 3 minus 1, that gives us 2. Right? This is just the cubic function itself. I'm not touching the cosine x inside yet. Now I'm going to do it. So now my power function is done. My function outside, my outside function is done. I'm going to go inside. So my inside is cosine x, right? So derivative of cosine x gives us negative sine x. Right, so and don't forget, this is multiplying. So my derivative of this becomes negative 3 sine x, and then cosine x squared. Okay, and this is multiplying. And I'm going to put this here. Okay, so sine x multiplied by negative 3 sine x, and then cosine x squared. So simplify this a little bit. This is cosine x cubed multiply cosine x. I'll get cosine x to the power of 4. And then in this case, this is all multiplying. So I'll get negative 3 sine x times sine x. I have sine x squared. And then cosine x squared. All right. So when we write powers for trig functions, we like to put the number between the cosine or sine or whatever trig and the variable. So now the cosine x to the power of 4 becomes this. Cosine x, and the power goes between them, minus 3 sine and x, and the power goes between them. And then this is cosine x, and again the power goes between them. And this is it. You can leave your answer like this. That will be correct, unless the question wants you guys to prove. All right. We are simply applying our knowledge on product rule, chain rule, power rule, all the rules that we learned from when we first learned about derivatives, and then we are incorporating that with finding derivatives of Ln functions, finding derivatives of exponential functions. So everything can be mixed up right now, but we don't have to worry about it once we know how to carry out these rules and kind of know where to find your so let's say if they differentiate Ln x, what happens, right? And if I differentiate e of x, exponential functions, what happens? If you guys got that, then you don't really have to worry about it. Just be careful though. Okay, this is it for now. I'll see you guys in the next video. Bye.